Entonces, we continue. Are you ready to pay attention? Everyone ready to pay attention? Yes or no? He said, yes, Emily, yes. Okay.
Yes.
Okay, super. Let's continue doing the rational function. Specifically, we study the vertical asymptote. So what is the definition? I don't understand very well, Professor, vertical asymptote. I bring one example to illustrate very well this idea. Suppose this example one. Actually, it's example two, because we did example one last class. I don't know, it's okay. X minus 3 divided by x squared minus 5x plus 6. Okay. The first thing you should do always is express it, our function, our rational function is the name of this function because it's the division to polynomial. Here some noise. Let me see. No, it's okay. Hey, Marlon off microphone. Remember, a rational function is a function that you have polynomial divided by polynomial, no? That's the idea, right? And you express it always in factorial form. On the top, no. The top stays the same. Okay, Lizzie. Let me see, say, no, it's activate my audio, it's activate. My audio is putting on. Guys, this is technical issue. I hear him. Okay, I try. Okay, don't interrupt me anymore. So you need to fix your problem. And the bottom, no, the bottom is trinomial. I factorization this trinomial. The combination obviously is 3 and 2 because 3 times 2 is 6. Karina not here, but Karina, I suppose you have trouble with the audio, Karina. And the sign is negative. Okay, I can hear you now. Okay, this. Okay. This is, depending on your computers, depending on your internet connection, is good or no. Basically, yeah, no more, Karina, because I try restarting. Okay, to say you have another problem, Karina. Karina, don't interrupt me anymore. Everyone here, no you. Okay, the domain of that function is all real number except 3 and 2. Okay, it's the bad guy. Because you plug in 2 or plug in 3, the answer is undefined. Entonces, maybe. Focus in mathematics. So you have problem, you watching the video in YouTube. Okay, posted today. Okay, entonces now I know very well que F evaluated in 3 and F evaluated in 2 both are to be undefined. That's the reason, because of division by 0, no? I mean, you know the division by 0. The thing I try to illustrate. Okay, these 3. These 3 is cancelled. Entonces when this 3 is cancelled, the new expression is 1 over x minus 2. And this expression, the original expression, is equivalent, not 100% to this. So it's equivalent except in 3 because I eliminated 3 and x not 3. But the important thing is that this is easier. You can manipulate with this. But I detecting that at x equal 3, we have a whole. The whole is always, guy, the factor que es cancel. Not always happen, but sometimes happen. And the other factor in the denominator que stay is x minus 2. And you take this, you put equal to 0, You get x equal to, and this is the vertical asymptote. Okay? So doing quickly, our graph look like that. Look, let me show you. Graph, graph, x, y. After we are doing decimal, of course. But now is at 2, the 1, 2, we have the asymptote, vertical asymptote. And 3, we have the whole. But remember the asymptote, we have 4 different behaviors. To understand the behavior specific in this, you evaluate the function n1, for example, and you evaluate the function n4. n3, no. This is 2. n1, 3, no, because n3 is a whole, in n4. When you evaluate n1, you can use it. It's unbelievable. You can use it either way, this or this. I prefer that way because it's easy. So 1 minus 2. So 1 over -1 is -1. And the point is the point 1 comma -1. 1 comma -1, and y-axis is this. And in 4 is 1 over 4 minus 2. 4 minus 2 is 2 is 1/2. And the point is the point 4 comma half. 4 comma half, this is 1, half is this, approximately here. So my graph, let me try to do my best, is something like that. Ooh, I don't know exactly what happened in the in another 0.5. I have a roughly sketch. But the most important is that in 2 we have the vertical asymptote, and the behavior is, you know, it's this behavior. But in 3 we have a whole. So in 3 you delete that part, and you are doing this. Look, in 3 we have a whole, a whole, a whole, a whole. But the whole is undefined. The whole is undefined. It's another kind of undefined. However, the position for that whole, if you want to determine, you evaluate the function in 3, but not in the original. So, you know, in the new one is 1 over 3 minus 2 is 1, this is 1. The point is 3 comma 1. 3 comma 1 is the whole, the position. And that's it. This is clear or no? The most important thing I try to explain is, Sergio Medina, I say yes. The most important thing I try to explain is, we have 2 kinds of the undefined. You have 2 kinds of value that is completely out of the domain. The first one is the most common, in my opinion, is the vertical asymptote. Okay, and we have also the whole. How you detecting whole or vertical asymptote? Easy. You take the original function. You are doing the factorization, the polynomial in the top, the polynomial in the bottom. The factor gets cancelled in this moment, represent a whole. And the other factor that stay in the denominator is the vertical asymptote. Done. No more complication. Let me show you quickly in Desmos. Let me share the screen with Desmos. Boom. Boom. Desmos. Do you see Desmos? Yes. Okay. This is example. Yes. This is the example 2. Look. Example 2 is the function what I call G. It doesn't matter the name. This is G. Do you see G? G is rational. We have the vertical asymptote at x equal to, and the famous point of the whole actually is 3 comma undefined. But okay, evaluate in the other function after you cancel out the factor x minus 3, que es the factor que produce the whole. You evaluate as 3 comma 1. This is the graph of the original que I have in blue color, including the whole. However, the graph of the new function after the simplification, wow, en red color es similar. Es very similar, except que the G, I call here G1 of X have no hole. And the hole is here. Look. And this is the graphic of the original. Let me try to put on available to see, and you see que wow. Let me flash in the red one, but it's the same graphic except in the hole. Super clear, in my opinion, no? Let me know if you understand very well this example or no. Yes, Emily. Okay. Guys, I promise que when I finish, que suppose que today, everything in the theoretical part of the rational function, I bring 4 examples. And also we dedicate one entire day to do the review for the most important topic for the test. Okay? So you see my whiteboard. Let's move on to the next idea. Good. Okay, the next idea is the horizontal asymptote. Horizontal asymptote. This is very similar to the end behavior that we studied in polynomial. So why? Because it's the same idea. You suppose that x is approached to positive infinity, it's a huge number, or negative infinity. But what is the most important characteristic in the horizontal asymptote and the rational function? Oh, que no es positive infinity or negative infinity. Well, maybe yes, but frequently no. So we have different behavior. Let me show you. Let me explain it. Suppose 3 scenarios in which you can see the horizontal asymptote. So in behavior, I need to find the f of x value of the function when the independent variable is x is a huge number. It's infinity positive or infinity negative. So now we have the situation. We have, for example, this kind of the horizontal asymptote. Okay, by the way, the horizontal line equation is y equal one number, no? Suppose que es 2. Suppose. One example. So, for example, our curve doing this behavior. For example, this is one hypothetical example. Another scenario, we have another horizontal line that represent the horizontal asymptote. And our graphic look like that. Oh, the reason it's like that is because maybe we have here a vertical asymptote. But the most important is que the curve, I put in red color, approach to the horizontal asymptote and frequently don't touch. It's a little bit different to the vertical because in the vertical asymptote never touch. And the horizontal sometimes, very weird, very seldom, but sometimes touch. So we have another scenario, for example, in which it's in my graph, the graph cross, but now it has totally approached to the curve. And today we study any scenario. And this super important point is the point in which the curve, our f of x function, cross the horizontal asymptote. Okay? So now, what is the rule? The rule is easy. So I call this rule of degree. I want to explain in detail, one by one. Suppose that we have this example. G of x is equal 7. No, I never solving this issue. This issue is your issue, not my issue. Every student hear me very well. It's your problem. I cannot solve anything. A ver, let me see. Listen, no? Everything is okay. Okay. Oof. Okay. Suppose this x equals 7x squared plus 2x divided by 4x squared minus 3. What is the rule of the degree? If the degree of the polynomial in the top, degree of the polynomial in the top, in this case, in this example, is equal to s equal the degree of the polynomial in the bottom, in this case also 2. Remember, degree is the highest exponent, this guy, 2, 2. The answer is yes, we have horizontal asymptote. Okay, I understand, but at what value? At what value? Well, you apply the dominant idea. Es obvio, dominant. What is the dominant idea? It's basic in the rule of the degree. Dominant function, dominant is like an behavior. Is the dominant monomial in the top is 7x squared. Why dominant? Because increasing factor. Why increasing factor? Because have the higher exponent. And you delete, consider it negligible, this guy, in front, this guy. Is dominant in the bottom, same idea, is 4x squared. 4 squared is obvious, get cancelled. And the answer is 7 over 4. So the answer of this question is yes, we have horizontal at what value? At the value y equals 7 over 4. But basically, very important, don't confuse it. So you have the same degree. So if the degree is the rule of p, que p es the polynomial in the numerator, is equal the degree of q, que q is the polynomial in the denominator. Entonces now then the conclusion is yes, we have. The conclusion is this conclusion. Yes, we have horizontal asymptote at what value? And the division for the dominant term, que is similar to the end behavior. Same idea, but end behavior on the top, end behavior on the bottom. Okay, let's see a couple of the example complementary to verify if you understand or you don't understand this idea. Suppose the function h is equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay. And another function que es p of x, que is x squared plus 7 divided by 11 minus x squared. My question is the same. My question is analyze horizontal asymptote using the degree rule. Entonces now you ask me two questions. Question 1, we have or we have no horizontal asymptote. And the second question is at what value is the horizontal asymptote? And the first one, h of x, you have yes or no? Answer me. Nobody know? Nobody know? Why no? What is the degree of the polynomial in the top? 2. What is the degree of the polynomial in the bottom? 2. It's the same degree. If the degree is the same, we have horizontal. Yes, yes. The answer is yes. Yes, it has horizontal. At what value? 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 Remember, a horizontal line is y equal one number. They need to determine it using the dominant idea. Dominant. What is the dominant? What is the dominant? What is the dominant in this specific example? What is the monomial in the top is dominant? This is the dominant. A ver? Ax squared is the dominant. What is the dominant in the bottom? 2x squared. Es obvio que 2x squared cancel y a divided by 2 es 4. Ok, entonces es mechanical. Is you take the coefficients, leading coefficients in the top and leading coefficients in the bottom. Entonces you divide in the story. Entonces es at x, y equal 4 in the same direction, to the left or to the right, to the positive infinity and the negative infinity. This is the beauty of the ratio. Okay, do you understand very well or no? Confusing? No? I understand. Okay. I understand. Everything you understand. Okay. I need help in the second example. This one. This one. We have yes or no? No, yes. Yes, I agree with you because degree here is 2 and degree here is 2. Yes. The answer is yes. It is. It has. My next question is what value? What value? What value? What value? Y equals something. Y equal what? 1. He said y equal 1. I don't agree with the y equal 1. Is negative 1. Because the dominant in the top is x squared, but the dominant is negative. Okay? Okay, super. And that's it. No, sorry, no. We have, this is the regular case. It's the most frequently cases. Most often you can see when the degree is the same. Suppose now when the degree is different. Suppose degree different. Suppose que the degree, suppose now, another example in which this is a rule of degree. We have 2 rules. Suppose que this example that I want to call f of x, is 5 divided by 4x squared plus 9. Entonces I need to investigate this horizontal asymptote. That's the thing that we're studying now. No? Okay, entonces now the degree, we apply the rule of the degree also. The degree of the polynomial is 0 because we have now x, so we can interpret it like x to the 0, okay, any number or variable raised to the 0 power is equal to 1. Now the degree here is 2. Entonces, when the degree, so if the degree of q, I call q the polynomial in the bottom, is greater than, no equal, greater than polynomial p in the top, the degree, degree of p, then we have also horizontal asymptote, pero ese es especie. no regular when the degree is the same. And the special is que always is a y equals 0. That makes sense. Because the situation that happen here is that this polynomial increasing factor, actually this is not increasing, stays the same, it's constant. So when you have a quotient, two quantity, and the denominator increasing, and the bottom no, or increasing no faster than this, so it's y equals 0. So in conclusion, guys, to determine the horizontal asymptote, we have two cases. So this is confusing, because the student don't remember very well. The regular scenario is when the degree is the same. Entonces yes, we have a y value and the division, the two dominant, the ratio, no, between two dominant monomial. And we have another special situation, I call it special, in which the degree of the denominator is bigger than the degree of the numerator. The question can fly in the air. Bueno, professor, what happens if the degree of the numerator is bigger than? Entonces no horizontal. We have another thing. Okay? Pero horizontal, que es the thing we study now, is this case. Okay? Let me put one example to clarify more this idea. Suppose. Suppose this example. Suppose the function f of x equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay? Okay, it's given. It's given that. Here I want to determine if we have or no horizontal. Okay. Do you have or no? Okay, the answer is yes. Good, it's yes. And what is the reason? Degree 2 both. Super. Okay, the answer is yes. It has. And the reason is because same degree. By the way, too. Second question is, at what value? The value is 4. And where come from that 4? Well, that 4 comes from 8, que es dominant, divided by 2. Super. But I bring this example to illustrate another thing. Okay. Now, in this example, when you have this conclusion, you are doing well. You almost have 100 points. You need to determine where, see if possible, no, frequently this situation don't happen if the graph of that function f of x cross it or no the horizontal axis. To investigate this situation, well, I know that this is my graph. I know that when the x approaches to infinity or negative infinity in both directions, the function approaches to 4, because this is the idea behind horizontal asymptote. So you enforce it. You copy that. You copy the function is given at the beginning, and you enforce it to be equal 4. Because I want to investigate. I know very well. This is the all real number line, infinity, negative infinity. This is the line y equal 4, horizontal asymptote. I know that my graph, I have no idea how it look like, but in infinity approach, I don't know if it's below or above, but I need to investigate in the middle here, cross it or not. This, I say that this is not frequently happen, but happen. So you set out this equation to investigate this idea, and you apply cross multiply. And when you apply cross multiply, you multiply, I copy ax squared plus 9x minus 5 multiplication 4 times 2x squared plus 1. Cross multiply. You distribute it, ax squared plus 4, and you try to solve for x. Wow, I can see okay, this and this is cancelled, and stay alive only 9x minus 5 equal 4. Now solve for x. I move 5 to the other side. 4 plus 5 is 9. Divided by 9 both sides. X is 1. So I discover que at x equal 1, my graph, the original f of x, crossed the horizontal axis at the point que obviously is the point 1,4, no? Oh, professor, where come from that 4? Because the horizontal asymptote is at y equals 4, no? Remember 4 is the value that I suppose here in the equation. Good? And this is very, very, very important. Very, very, very important point. Very, very important. I want to show you we have not all elements to do any graph, but I verify some idea in this move, no? To understand little by little, because there's too many details in the rational function. Little by little, this complicated thing. Okay. Let me see example 3 or no. Oh yes, it's example 3. Look at that. Example 3, guys. Look at that. In this example, we have one horizontal asymptote here at y equals 4. Exactly, we investigate. And also, we investigate that our function crosses the horizontal axis at the point 1,4. And the aim behavior, let me show you aim behavior. To the positive infinity, you see how our graph approaches asymptotically 54, 59, wow. And also in the infinity bar, you see how approaching to positive 4 when the value of the independent variable x is a huge number negative. Do you see the idea? Do you understand very well or not? Okay. I promise in your moment I want to integrate this concept in 3 or 4 example. A strong example to cover every possibility. Okay, let's come back again to the whiteboard. Now we study a new thing. Let me share the screen first. Let me try to don't forget today share screen. Okay, whiteboard. Do you see whiteboard, guys? Or no? Okay, good. Now we study another important asymptote. By the way, the last one is the slant asymptote. The slant asymptote we have in the scenarios que the degree, so if the degree of p, que es el polinomial in the top, numerator, is greater than 1, is greater than 1, is greater than 1, so greater than 1, but the greater than 1 plus the degree of q. Let me write no in words, in number 1. So basically it's equal the degree of Q plus 1. But not greater, sino equal. Let me translate this to the one common language. And then we have slang access. Okay? Example. Example to understand. Example clarify everything. F of x is equal x squared plus 1 divided by x minus 1. Okay? I have no idea. Start my problem. My problem say, well, degree, analysis of the degree of the polynomial P is 2. And degree of the polynomial Q is 1, linear. Therefore, satisfy perfectly the condition, that is 1 plus 1 is 2. And si es greater than, but not 1, I don't know, suppose another example, que es x cubed plus 1 divided by x minus 1, entonces we have, because degree is 3 and degree is 1. Entonces, no, this is completely out of the definition. No. In this case, yes. It's greater than, but 1. No, suppose degree 4 and degree 3, or degree 5 and degree 4, 1. So we have a slang. And what is the slang? Well, the slang is asymptote also, but no horizontal, no. No vertical, no. It's an inclined line. Slang. I don't know if the slope should be positive or should be negative. That depends on the problem, no? In this specific example, let me try to do my best. In this specific example, you perform or long division, or in this case, you can do that synthetic division. I prefer long division in this case because not necessary in the example that we're doing today, the polynomial and the denominator is linear. And you know, synthetic is only valid when the degree is 1 in the divisor. But okay, no problem. Let me try long division. So you copy x squared and you organize. If some element is missing, you put 0x because the polynomial in the top we have no linear, we have no x and 1 divided by x minus. Long division. And the answer is x because x times x is x squared and x times negative 1 is minus x. By subtracting, you change the sign. This is cancel, as always happen, and this is x, and bring down 1. So now, I finish, no, I don't, because I finish when the degree of the remainder of the hypothetical remainder is less than the degree of the divisor. In this case, 1, 1, no, I don't finish. Not plus 1, because 1 times x is x, and 1 times negative 1 is negative 1. By subtracting, you change the sign. This is cancel, as always happen, but this is no, that's 2. So what is the conclusion? Well, the conclusion is algebraically, this quotient is equivalent x plus 1, that is the quotient part, plus remainder gets 2 divided by divisor gets x minus. So actually, I don't discover any new. This is perfectly equivalent 100% algebraically with this. However, I can see clear, que the linear part, que is this part, represent the line y equal x plus 1. And this line is the slang. Well, as always, you do the graph of the line. You for example, you copy, but let's do it quickly, the graph of this function, xy. And remember the equation for the any line is mx plus b. Okay, and b represent the y-intercept. In our specific example 1. I plot that point. The point is 0.1, and the slope is also 1. And you apply wrong and rise. So slope is always wrong and rise. And wrong is 1, rise is 1 because the slope is 1. Okay, so it's positive. It's in the point over, rise wrong. It get the second point. Yeah, do the graph of the line, but it's asymptote. It's a slant asymptote, and you put dot. This is the graph of the hour asymptote. Is y equal x plus 1. By the way, this is completely out the game. I discovered another asymptote, but it's vertical. Okay, it's x minus 1. So you take x minus 1. I take advantage of this moment to review again this. Equal to 0. This is vertical asymptote at x equal. Okay, nice. Here and 1. We have one vertical asymptote. Okay, by the way, the equation for this vertical asymptote is x equal 1. So you see x equal 1 number, any constant is vertical line. And the graph, when you are doing elegant in decimals, look like that. And some more detailed additional point. I promise guys que I want to teach you by hand and after verification, double checking with decimal, any example. Now we study only the theoretical part. Theoretical. I have another example of the slang to start directly to the complicated problem. Any question, you follow me the idea, so you are doing, bueno, professor, pero always we are doing, following, okay, following. It's possible doing scientific division in that case? Yes, it's possible. Why is possible? Because the degree of the polynomial and the denominator is linear, and always this situation happen, we can do no these divisions. You know, you are doing the another division that maybe you prefer or you like. Okay, is for example 101. Look, what means 101? This coefficient is 101. And you divide it by 1. Remember, it's opposite sign of this. In the long division, you put -1, but on synthetic, you put different sign. Bring down 1. 1 times 1 is 1. 1 plus 1 is 1. 1 times 1 is 1. And 1 plus 1 is 2. And these 2 represent this remainder. And the answer is this, case y is equal 1x plus 1. X to the 0, x to the 1, que actually is x plus 1. Super good. One more example about slang. Slang. One more. Easy, not complicated for you. Suppose this. Suppose the function g is equal to x squared minus 5x minus 3 divided by x minus 2. Immediately I faced this problem, I see, wow, degree of the numerator is 2, degree of the denominator is 1. So the degree of the numerator is 1, greater than 1, the degree. I said, yes, maybe you have no, actually, for sure you have. It's long. To find the equation of the line is not too easy like a horizontal, is you are doing division, no? What division you prefer? Long division or synthetic division? What division you prefer doing? In this case, I can do by synthetic or no? No or yes? Synthetic. Long division. Yes, what means yes? Okay, we can do it by synthetic, right? Yes or no? Yes, we can. What is the reason that we can? Because what is the reason that we can do that? because it's linear. Who is linear? Divisor is linear. Divisor linear. Divisor linear. Linear mean, guys, degree 1. Equivalent, degree 1. Okay, super. So now it's easy. I take advantage. There's 2, -5, and -3. I copy just the coefficients here. I copy 2. 2 positive, right? And opposite sign. Bring down 2. 2 times 2 is 4. -5 and 4 is -1. -1 times 2 is -2, and the answer is -5. Therefore, I agree 100% that our function, let me erase that part, is algebraically equivalent to okay, 2x minus 1, get that part, minus 5 over x minus 2. And that part represents this line asymptote. It is, you know, y equal to x minus 1. Okay, do the line and dotted line, of course, that represent this line. Super cool. No problema. Let me see. No problema. No problem. No problem. MP. No problem. Okay, good. Cool. Get user start and record. Wow, you're late. Okay. You watching the video in YouTube. Okay, so now this is a crucial moment. Inflection point, in which I want to explain what is the methodology can we apply anytime to do the graphic of rational function. It's a little bit more complicated, no? Because we have asymptotes, you know. Polynomial was super straightforward. Rational, no. Complicated. Entonces now we have 7 steps. 1, 2, 3, 4, 5, 6, 7. The one that you are doing step by step. I want to see in the test, in the reading test, step by step. What is the step 1? So the step 1 is express the original function in factory form. Okay, this is the first thing in few words you should do is factorization of the polynomial at the top, factorization of the polynomial at the bottom. Okay. Suppose elementary kindergarten example, suppose x minus 4, x plus 5. Suppose que did the factorization, x minus 4, x plus 6. Entonces, in this moment, you see, wow, I discovered x minus 4 is common factor. I cancel out, and I know that at x equals 4, we have a whole. And so far, after the step 1, we continue working, no using the original complicated, no. We're using the new one, that is x plus 5 divided by x plus 6. It's equivalent 100% to the original except at 4. Because in 4 I detect it gets a whole, and when you are doing the graph in 4 you put a whole. Boom, and that's it. No problema. Step 1. Not P. MP. Step 2. Important. In any graph that we are doing so far in this subject, 2 important points, super important points are y and z. Okay, by definition, y and z is the point in which the curve crosses the y-axis. And what is the formula, Professor? I don't remember. Well, the formula is easy. You take the function, evaluate it, boom, and that's it. Okay, And suppose that the answer is 20. Entonces the point is 0,20. Okay, entonces in conclusion, the formula for the y-intercept is 0, f evaluado en 0. Step 3. X-intercept. This is very, very similar to the polynomial in a set. The formula is f of x equals 0. Because I assume the y is 0. But I have more. I have more important thing. Look, I know our function is rational, and we have p divided by q. And you enforce it to be 0. Therefore, this is equivalent 100% to say that p of x is 0. Now you take the polynomial in the top after the factorization, after the cancellation of the whole, and you enforce it to be equal to 0, the top. I don't care the bottom part. This is not important, totally irrelevant. Because you know very well, when you have fraction, and the fraction is equal to 0, it's because the numerator is 0. I don't care the denominator. The denominator is not important. That you take the part in the numerator, you enforce it to be 0, and you focus in the solution for this equation. Okay, sometimes have one solution, or two solutions, or three solutions, depending the example and the degree of the polynomial, and you plot that point. Okay, you see in the example, you have maybe 1, or maybe 2, or maybe 3 solutions of the polynomial. Everyone follow me so far? Step 4, we see in the example, I promise. If we don't finish today, we continue Wednesday. The important step 4, verica asymptote. Verica asymptote. And what is the formula, professor, to find the verica asymptote? Well, okay. When you simplification the wholes, we have that. And you take the polynomial in the bottom. It's completely opposite to this idea. You take this. You take this. You take this. In this case, you take the top. No, not the top. The bottom, and you enforce it to be equal. And you solving this equation. And the solution of this equation represent the verica asymptote. And in this moment, I highly recommend that you are doing a roughly sketch by hand in which you have positive infinity, negative infinity, and the solution of this equation. Suppose that I solve it. You know how you solve it. You see in the example, but it's similar to the polynomial. Suppose x equal 1, x equal 2, x equal 3. Okay. Suppose 1, 2, 3. Funny. So this is 0, this is 1, this is 2, and this is 3. We have 3. 3 what? 3 vertical. And this is important because using this asymptote to represent the partition of the all real number line, and also why not? Suppose f and 0. No, f and 0 no. No, mistake. Suppose that the solution for this equation to represent the x-intercept is x equal negative 1. Negative 1. I know that my point is the point 0, no. Negative 1, 0. Negative 1, 0. So you plot that point. It's here. Negative 1, 0. Here. And just in this moment, I take advantage the all partitions in the all real number line can represent the x-axis. The y-axis don't care. I don't care for a moment. Now, you select, for example, one point, because the last step number 7 is plugging in an additional point. Suppose I select one guy here, 4. I select one guy here, 2.5, in between. No? I select one here, 1.5. You select here 0 maybe, or you select negative 2. So this give me information what is the important partition of the x-axis, the domain, and selection arbitrary point, not exactly fixed points, total arbitrary. One student select different to another student, and the answer is the same. Okay, this is my recommendation. This is not mandatory. The book don't talking about this, but I recommend it. Now, step 5 is important is the horizontal or no and slash slang asset. I want to erase that part. And this idea is completely exclusive. So if you have horizontal, for sure you have no slang. As you have slang, we have no horizontal. This is mutual exclusive. And you are doing the analysis of degree. I explained at the beginning, no? See, we have the same degree. Yes, we have. It's regular case. So you have, for example, the degree of the bottom greater than the degree of the top polynomial. Yes, we have special horizontal asymptote at y equals 0. And say the degree of the top is greater than 1, the degree of the polynomial at the bottom, you have slide. Otherwise, no, we have nothing. Right? Now, step 6. Okay, the frequently students forgot this, but in my opinion is super important, is investigate the symmetry. Yeah, I want to explain symmetry. Why it's important. Symmetry is, you remember college algebra, even function, or odd function, or neither function. The test to prove que es even function is you replace x for negative x and nothing happens, stay the same. That means that our function is completely symmetric in the negative part and the positive part. Or in other words, symmetric will respect the weights. And this is important because you compute additional point. I know, suppose negative 1, 2, 3. I know very, very, very well. See, I prove que es even, que negative 1 and negative 2 and negative 3, we have exactly the same value of the y. So this saves time because the negative bar and the positive bar is the same y. Because I saved time. And also I save time, it's odd because when you replace x for negative x, you get opposite sign of this. So this is symmetric, but we respect the origin. When this situation happens, suppose that the curve look like that. This is 1, this is 2, this is 3. Have the corresponding value to say negative 1 and negative 2 and negative 3. We have exactly the same value, but the opposite sign. How do you know? Because we have negative in the front. And you also save time. Because you compare f and 1. Suppose que f and 1 es 10. Entonces f es negative 1 es negative 3. Because it's odd function. And even no, it's fantastic. F and 1 is 10. And f and negative 1 is 10 also. Otherwise, que es the most popular scenario, que es neither. Okay. And neither is no special, it's completely ordinary. Entonces, unfortunately, we need to plot the positive bar and the negative bar completely independent 2 times. Okay? Now, but we take advantage. You will spend a few seconds to prove the symmetry that I want to show you in detail now. And that's it. And step 7, que es the last one, is compute additional point. What is the criteria for the additional point? You plug in the function any point, but no arbitrary, no crazy. No. Using the partition that I explained before here. When you have in your hand the vertical asymptote number 1, vertical asymptote number 2, vertical asymptote number 3. I don't know if we have another or 2 vertical asymptotes, or 1 or 3. I don't know. and the exit set. Exit set 1, exit set 2, and so on. After you have this information, you select completely arbitrary and between each interval one guy and plug it in into the region. This is important. The other is not important. This is important. How many? Well, no. The conclusion is if you select more points, our graph is more accurate. However, what is the limit, professor? Well, the limit is take at least one guy inside each interval. Do you understand the basic idea? Okay. Entonces no more blah blah blah. Too much. Too much. Too much. This is mathematics or is English? No, es mathematics. Entonces let's go to the example. Example 1 strong. This is example 1 strong example. A strong example que include everything, guys. Include everything. The 7 step. Suppose the function is given. F of x equal 4x divided by x squared minus 4. Okay. What's the question, professor? And the question is do the graph. Include everything. Do the graph. Include whole, include asymptote, include points, include intersecting, include everything. Okay, what is the step 1? Factorization. Well, our function looks like that. In the top we have monomial. I cannot do anything here. And this is the difference of a square. You can factorization using the formula that you know very well of the differences of the square. In our specific example, x and 4, the square root x squared is x, the square root 4 is 2, plus or minus. Okay, this is a factory form. Nice. This is the original, and this is the new one. And you can see, there are some factors that we cancel out. No. No common factor that you cancel out. Therefore, conclusion, no whole. Our function have no whole. Okay. Okay. Not bad. I like this. But I need to detect in the whole. The way to detect in the whole is factorization, and you analyze, you have common factors to simplify. Step 2 is y and z. Evaluate the function in C. It's easy. You plug it in where? In the original or in the factory form? Either way. I like the original. 4 times 0, 0 squared minus 4. 4 times 0 is 0. And 0 squared is 0, minus 4 is negative 4, and 0 divided by any number is 0. When this situation happens, guys, normally 0,0 is that point is both. It's x in a set and y in a set. Well, no, not necessarily. Depending on the degree of the polynomial in the top, maybe we have another x in a set. But no, I don't know. Step 3 is f of x equal to 0. Actually, I don't care the bottom part. To find that, no, I don't care the bottom part. I take b. Okay, b is 4x. Wow, easy equation. Divided by 4 both sides. 0 divided by 4 is 0. This is no surprise. This is the same conclusion. 0,0, que es the origin, is both. It's y and z and x and z. Super cool. Super cool. Step 4. Step 4 is the verified alpha. Very important. Verified alpha, remember, you take the polynomial in the bottom. Okay, you take either way, the way you prefer. Factor 4 or the original. Let's do them both. Curiosity. You take, for example, x squared minus 4 equals 0. You enforce it to be 0. So the formula is q of x equals 0. And you solve this quadratic equation using square root method, square root both sides, x is equal plus or minus 2. Don't forget, when you find the square root, you put double sign, no? Plus or minus. Another two say, no, I don't remember very well this. Maybe for me it's better. Take the factor 4, gets x plus 2, x minus 2, and force it to be 0, and you separate into factor. Therefore, this is negative 2, and this is positive. Okay, and this is the super, in my opinion, super important moment in which you are doing the sketch. The roughly sketch by hand, in which you have all real number, and we have two asymptotes and two positive. Suppose this is 0, 1, 2, 1, 2. We have one vertical asymptote and negative 2, and we have another vertical asymptote and positive 2, and we have in 0 the intercept. Okay, therefore, when I select the number to plug it in, I would like include, for example, maybe 3, or maybe 4, or maybe negative 3, or maybe negative 4, or maybe negative 1, or maybe positive 1. Because it's the guy inside this interval. Remember, okay, 0 is also included, but no, I don't put dotted line because it's no asymptote. It's also partition, but hypothetical, imaginary partition. I put in blue color, but no, actually no partition. Boom. Okay. What about step 5? Step 5 is the step confusing case, horizontal or snap. Well, okay, I am doing the degree analysis. Let me start at the beginning. And the original equation is 4x divided by x squared minus 4. Wow, degree of the polynomial at the top is 1. Linear, good. And degree of the polynomial in the bottom is 2. Because I know, okay, the special case say when the degree of the polynomial on the bottom is greater than no 1, so greater than 1 plus 1 plus 2 plus 3 is greater than. In general, yes, we have horizontal asymptote at y equals 0, because it's a special case. No division, leading coefficient, no, dominant, no, it's special. Aromatical, see, I have horizontal, we have no snap. No, definitely no. This is completely disjoint situation. No, it's not connected. And step 6, you are doing quickly. 6, we are doing quickly the analysis of symmetry. Quickly, in 2 seconds. Entonces, what should I do? Well, you take the original function que is. Let me see, the original function was f of x equal 4x divided by x squared minus 4. And you replace f of minus x. Because when doing this action, you make reflection. Entonces, 4 times minus x divided by minus x squared minus 4. Actually, this is negative 4x. And this is when you square become positive. Entonces, x squared minus 4. And when you compare this guy and this guy, you see clear like a border. Okay, it's exactly the same expression except opposite side. So satisfy this condition. Satisfy this condition. Okay, f evaluate negative x is equal minus f evaluate x. And this is a typical odd function. Yeah, I take advantage of this fact. Because when you include the additional point, I include only the positive. I like the positive. And the negative is the same, but opposite sign. And stage 6 is exactly this step, in which I include additional points. How many additional points? Minimum is, well, I take 1, I take 3, I take, that's it. Because I know a negative 1 is the same value of the positive 1, but opposite sign. Suppose that this guy is negative, this guy is the same value, but positive. And suppose that this guy, I don't know, si is positive, this guy is negative, and negative. And that's it. You can select more if you want. Of course, you can. It's much better. Actually, in decimals, I am doing more, but this is the minimum. So you evaluate, for example, add R1, the function evaluating 1, and the function evaluating 1 is 4 times 1 over 1 squared minus 4. 4 times 1 is 4, 1 squared is 1, 1 minus 4 is negative 3. The answer is negative 4 over 3. Okay, in decimal, if you want to see more clear, is negative 1.3 repeated. That point is the point 1, comma, well, negative 4 over 3. Yeah, I know very well. Okay, this guy is negative 1, comma, positive 4 over 3. Same value, but opposite sign. I take advantage that the function is odd. Okay. Another guy important. 3. It's 4 times 3 divided by 3 squared minus 4. 4 times 3 is 12 divided by 9 minus 4. And 9 minus 4 is 5. It's 12 over 5. In decimal approximation, well, actually it's minus 2.4. You put in the decimal and the fraction, either way, you put, for example, the point 3 comma negative 2.4 and negative 3 comma positive 2.4. I write in decimal, but no, you put 12 over 5. In decimal, you can put 12 over 5. One thing I forgot, and this is important. I forgot important. This is too many details. I have practiced. However, I forgot something. Remember, when you in the step 5, you checking the horizontal asymptote. Remember, I need to verify if my asymptote or my curve, crosses or not the horizontal. Que sometimes happens, sometimes. The answer is yes. And by the way, it's the same famous point 0,0. You remember very well that it's x and z, y and z, and also it's the point in which the curve crosses the horizontal because it's 0. It's a coincidence. In the story. And now, any two words we can verify in them right now in a few seconds. Okay, example 5, I call in decimals. Let me switch into the screen to the decimals. You see? Okay, I copy the function, the original function. Okay, I take advantage the function notation. In decimal, we can use a function notation. Okay. Okay, you see clear the vertical asymptote, look at that. X equal 2, x equal negative 2. And the horizontal asymptote is y equals 2. Oh. And I take, I take the y and z, x and z, is 0,0. I taking 1, 2, 3, 4, 5, 6 points extra. Actually, it's just 3. I plug it in 1, I plug it in 3, I plug it in 4. And the value is exactly the same value of the y, but opposite. You see clear, looking the graphic, the idea of the odd function. Yes, Emily say, yeah. You see clear the idea behind odd function. Odd function is symmetric with respect to the origin. What mean that? That means, let me try to explain the board. So the graphic okay, the graphic, suppose que is something like that. 0, 2, -2. Let me copy at least one part, not all of them. Is something like that. Well, the rest is like that and like that. You see, so you are in the origin, and you put the arrow in this direction. You put the arrow in the opposite direction, and this arrow have the same length. This is symmetry with respect to the origin, que es a fantastic characteristic of the odd function. Okay, super cool. Super. Okay, let's move on to example 2. A strong example. Que incluye everything. Incluye factorization, incluye XNZ, YNZ, periodic ácido, horizontal ácido, o SLAM, incluye when you have horizontal, you need to verification if yes or no, cross the horizontal, because sometimes happens, sometimes no. And symmetry and additional point. Okay, let's do it. Next example, example 2, strong, is g of x is equal to x squared minus 3x minus 5 divided by x squared plus 1. Oh, okay, guys, don't try to do no horizontal, no, step by step. The first step is factorization. Step 1, factorization. Let me try. I copy one corner of the piece of paper. I want to copy in one corner of the piece of paper the polynomial in the top. I try to do my best to make the factorization. You multiply this number and this number 10. I don't care, this sign is not important. And the combination is 5 and 2. So 5 and 2, 5 and 2 is 10. And somehow 5 minus 2 is 3. Okay, super. This is the combination. And you copy 2x squared minus 5x plus 2x minus 5. And you separate these 3 using 5 and 2. And you create now not trinomial anymore, no, polynomial. And you apply factorization by grouping. You find the GCF in the first couple, and you find the GCF in the second couple. And the first couple, the GCF is x, 2x minus 5. In the second couple, we have no GCF. Well, actually, we always have GCF, que es 1, 2x minus 5. And you factorization, 2x minus 5. And in the last parenthesis, we have x plus 1. Actually, I replace no trinomial anymore to binomial, 2x minus 5 times x plus 1. Guys, I'm doing that way, maybe for you it's not good. You're doing your own way. I don't want to explain factorization here. Okay? Now at the bottom, look at that, what happened at the bottom. At the bottom, I know very well that the difference of a square is the factorization of a plus b times a minus b. It's classical. However, the sum of a square Prime. We can know factorization. This is irreducible quadratic equation. Irreducible quadratic. Another way, bueno, I memorize this, but suppose that you don't remember. Okay, no problem. One fantastic way is similar to the thing we're doing in the polynomial. In the polynomial, you take, for example, x squared plus 1, you enforce it to be 0. And you solve for x. X squared equals minus 1, apply square root of y. X alone is plus or minus, or square root negative number is sign. If the answer of the solution of this is imaginary or complex, it's because the polynomial in the real field is impossible to make a factorization. Okay? Now leave it at that. This is the factorization. I finish the step 1. Unfortunately or fortunately, I don't know, we have no hole because we cannot simplification anything here. No hole. Okay. Step 2. Easy. Y and Z. Evaluate the function en 0. The name of the function is G. G evaluate 0. Or it's easy because in the top we have -5. 0, 0, -5, and the bottom we have positive. And -5, and the point is the point 0, -5. This is an important point, and we need to take it. And the graph. Step 3. Well, it's the x intercept. And x intercept, you take the polynomial p, and the top equal to 0. And of course, I take advantage. I did the factorization before. Actually, I copy 2x minus 5. Parenthesis x plus 1 equals 0. And I apply one more time the zero factor property in which you take each binomial equal to 0. Okay, let me finish this. 2x equals 5 divided by 2 divided by 2. X is equal to 5 over 2. Que es 5 over 2, 0. Because I assume que the y is 0. Look at that. If you don't like the fraction, no problem. Because this is equivalent to say 2.5, 0. You put in the calculator. And the second is x plus 1 equals 0. And the factor is x equals minus 1. And the other x intercept is the point -1, 0. Oh, good. In this example, different. In this example, we have only one y-intercept, but we have 2. Professor, I can see the whiteboard. Wow. Any more? I switch it on. No? Wow. All right. Everyone, I can see. So the students say, Martin Sepe say, I can see. Okay, let me know, guys. You can see or not? Sergio, I see. Lizzie, you have big problem with the internet or computer. You need to fix it, that situation as soon as possible. If you don't fix it, you cannot take this class. Okay? Because it's online, guys. You need device, you need electronic, you need technology. No? Emily? Okay, I see. It's now. Thank you. Okay. Okay, entonces what should I do? Bueno, voy a step number 3, no? Oh, number 4 now. Number 4 is, okay, it's important. Step number 4. Step number 4. Step number 4 is the asymptote. What kind? Vertical. And vertical asymptote, you take the polynomial q in the bottom and force it to be 0. What is the polynomial at the bottom? I don't remember. Bueno, is look at that, this guy. Oh, but I did that. I put it here, where here equal to 0, and the answer was imaginary or complex. That means que our function have no vertical. Okay, this is classical. In algebra, guys, when you want to find something, okay, I set out the equation associated with this something. See, the answer that you get is imaginary or complex is because the something that you pretending to find do not exist. So we have no verticals, right? Okay, super. Now let's move on to step 5, que is the analysis of the degree in order to verify horizontal asymptote or slant asymptote. Okay, I come back at the beginning. The beginning is, I want to copy again. It is 2x squared minus 3x minus 5 divided by x squared plus 1. And remember the degree analysis. Okay, what do you think? We have horizontal, yes or no? No? All right, yes. You say yes, we have. Yes. At what value? At what value? Why good? Okay, why good? Yes, we have horizontal. Of course, we have no slant because they are mutually exclusive. And no vertical. Super. Entonces now I need to verify see the function cross or not the horizontal. Yes, always, guys. In the last example I forgot, but now I don't. You copy if in the middle, not in the end behavior, in the middle, this expression 2x squared minus 3x minus 5 divided by x squared plus 1 should be equal to, and you cross multiply one more time. 2x squared minus 3x minus 5 is equal to 2 times this is 2x squared plus 2. Wow, this is cancelled. And state this equation, get minus 3x minus 5 equal 2 minus 3x is equal to plus 5, get 7 divided by negative 3 is x equal minus 7 over 3. Okay. And by the way, 7 over 3 and this decimal is negative 2.3. Repeated, yeah. Okay. And the point to set the conclusion is yes. In one moment of the graph, you can see how our function, this function, g, crosses that horizontal asymptote at the point negative 7 over 3. By the way, the point, the actual point is negative 7 over 3, 2, no? Because the y value is 2, no? Okay. Now, symmetry, understand? No? Yeah. Es obvio que es no symmetry. One quickly inspection que es no symmetry. Look, the even is even. Purely even. Look, this is even, but this is not. This is even, but this is even also. But one guy que es linear here, screw up everything. So no even, no odd, is neither. Okay, this is the most common. Even and odd are special, and you take advantage of this special. But why not? Entonces I come back. We have no the famous partition that we are doing at the old problem. I forgot. The reason I forgot was because we have no vertical asymptote. But we have, okay, we have something. We have something. I forgot to do that part. It's a positive infinity. It's a negative infinity. We have no asymptote, no dotted line. But we have two externals, okay, it's at 2.5 and negative 1. Okay, this is 0 in the middle, 2.5 is 1, 2, 3 here. This is 2.5. No asymptote is the point is 2.5, 0, and negative 1. But I'm using like a partition, no? So I select this point, negative 1, 0. I select, guys, suppose in my paper I select 1, I select 5. This is 2, 3, 4, and 5. Why not? And select negative 3. Negative 2, negative 2. So, and you evaluate G in 1. You evaluate G in 5, positive. And you evaluate G in negative. And this is pretty easy. Just plugging in the original using the calculator in the story. The answer is negative 3. The answer is 1.15 positive, and the answer is 2 points. And we have 3 additional points. Okay, the point 1, negative 3, 5, 1.15, and negative 3, 2.2. Okay, it's supposed to be enough. You plugging in everything together, boom, and you see your work. I know it's consuming time. That is the reason in the test. I have 2 questions of this, but you have 4 days for solving this and the rest. So now, let me try to switch into GeoGebra. Over there, switching GeoGebra. Okay, example 6. No? Yeah, example 6. I call here in GeoGebra. Bam. Look at example 6. Do you see or not? Let me recap. Remember, we have recap. You have look in green color. You have 1 in the set, que es 0.95. We have 2 x in the set, que es 2.5,0, and 1,0. Super cool. We have no vertical asymptote. No. We have image. What means image? You see Desmond or no? Go to context view. Context view. To change the background, I suppose. Let me see. No, it's okay. My question is, you see what you see Desmond or no? We need to yes or no? Alright, I see. Okay. The focusing and the explanation. I compute, remember, I compute the famous point. Look at that, the point negative 2.3,2, is the famous point in which the curve, que es in blue color, the curve crosses the horizontal asymptote, que es y at y equal to. We have in red color 3 additional 0.5, 1.15, 1, negative 3, and negative 3, 2.2 positive. And you have wrong idea how it look like the graph. And see you are doing well or no. Suppose you plot this in a piece of paper, you need more points. However, in Desmond, no, because in Desmond you put the equation, automatically the equation cover any point. However, you emphasize using the minimum point, in this case 3 points. Super cool. I suppose, no? Okay. This is example 6. Let me see what is example 7. Oh yes, okay, no problem. Okay, example 7. Let's come back to the whiteboard. Example 7, whiteboard. Okay. You saw the whiteboard? You see now? Cool. The example 7 is the name and the decimal. h of x is equal to x squared plus 9x plus 4 divided by x plus. Okay, step by step. We apply, guys, the 7 step. I appreciate so much if you are doing in this order. 1, 2, 3, 4, 5, 6, 7. Step 1 is factorization. Now, factorization, you take the original polynomial, the top. You multiply, this is 8. And the combination is 8 and 1, because 8 times 1 is 8, and 8 plus 1 is 9. And you break it down, this is like a 2x squared, I forgot square here, plus ax plus 1x plus 4. And you apply grouping. Factorization this couple, and factorization this couple. We are color. That couple. And the great common factor is 2x. This is x plus 4. And the great common factor is 1, because we have no common factor. Therefore, x plus 4 factor out again, one more time, 2x plus 1. And the factorization is, you know very well, it doesn't matter the order. We copy x plus 4 times 2x plus 1 divided by x plus 2. One more time happen, and it's very, very weird. We have a whole, but I intentionally, in the review, in the test, I put at least one example to include a whole, but in this case, no whole. No whole. But you have the factor 4. Okay. Now, the next step, I don't want to go to step 1, 2, 3, because I memorized the order, no? And the name is the y and x evaluate the function is 0. And the function is 0 is 4 in the top, 3 in the bottom. And the point is the point 0, 4, 4. You see how we are doing fast, no? Okay, in decimal, you want to have some idea, is 0, 1.3 repeat. Good. Now x in a set. X in a set for the function is 0. Oh, no function, p is the polynomial in the top. And who is the polynomial in the top? This guy. But I take advantage of the factor 4. It is x plus 4, 2x plus 4 equals 0. Okay, I'll apply one more time. Zero factor property. Zero factor property is x plus 4 equals 0. Therefore, x is minus 4. 2x plus 1 equals 0. Therefore, x is equal to 2x is equal to minus 1 divided by 2, both sides. X is equal to negative 1. Conclusion. Conclusion. We have two x in a set, is at the point negative 4, 0 and negative 1/2, 0. Super cool. Okay. Now, what's the next step? Well, the next step is analysis of the Beck asymptote. Okay, vertical asymptote is you take Q of x equals 0. Who is Q in our problem? Q is x plus 2. Look at that. This guy. Or this guy. It's the same. You enforce it to be 0. Therefore, it's negative the solution. This is the crucial moment in which I am doing the sketch of the partition. This is my famous all real number line. Infinity positive, infinity negative. We have one vertical asymptote. This is 0 in the middle, and negative 3, negative 1, negative 2, negative 3. And negative 3 we have vertical asymptote. But we have the y-intercept set in negative 4 here, and negative 1/2. In negative 1/2, this is negative 1, this is negative 2. I suppose it's in the middle here. This is the point, negative 1/2, 0, and this is the point here, -3, -4, comma 6. Entonces, en the paper que I have in my hand right now, I take the point auxiliary additional, I take -5. Another student take -6, yes, okay. -2, so in the middle, think about -2. And 1, but 1%. You take this. This is the minimum. This is the minimum required. Es obvio. Bueno, no, sorry. I try to finish, pero no. A ver. Time is over. Oye, time is over. Okay, time is over, guys. Sorry. You are too kind to continue watching me. Pero no. Stop. We continue next time. We continue this and 2 more exams. And we start the last topic. And that's it. Entonces, everything was okay today or no? You understand very well or not? You have to practice. Don't worry, you relax. You continue now doing the lab, the homework online in Alex. No? Any question? Even tomorrow, I am in the lab online from 11 a.m. to 4 p.m. And you try to reach in his schedule the tutor Jose Alegre. No, Jose Alegre, no, sorry. Alejandro Martinez. Okay? In the WhatsApp group, he is doing the review. I sent to him the package for doing that. Okay? Okay. Have a nice day, guys. Thank you. It's a pleasure always with you. I like this class.
I have a question.
Please go ahead.
For the Alex exam, is it going to be time?
Yeah, of course. The Alex is due May 25th, I guess so. But don't worry too much for this. You communicate with me by email because I know at the beginning, the semester, there are some problems with the code, financial aid, whatever. Well, financial aid is not important because you're using the financial aid code and you start, you get inside, you sign in as soon as possible. But okay, you communicate. Online class is important communication with the instructor. Suppose the due date, I checking, I see that you don't see anything, I put 0. But if you communicate with me, entonces now I understand. Now I extending a little bit your due date, better for you. Okay? Communication. In the second test, no, it's different. I suppose you know.
Profe,
right?
I have a question, Profe. Until what time is math lab open?
At what time? My schedule, you say?
Yes, like the
11 in the morning, 11 a.m. to 4 p.m. in the afternoon.
Thank you so much, Profe. Have a great rest of your day.
Bye, guys.
Bye.
Bye, Profe.